going to be doing lecture 21, applying the quadratic formula. So as we learned last time, we did the proof of the quadratic formula, and we learned that we can write it as x equals negative b plus or minus the square root of b squared minus 4ac. And everything is divided by 2a. All right. So this formula can be used to solve all quadratic equations. And this is for ax squared plus bx plus c equals 0, where a, b, and c are real numbers. A, B, and C are going to be real numbers. And A can never be 0. Because if A was 0, then we'd be dividing by 0, right? In that denominator. So we can't let A be 0. But B can be 0 and C can be 0. That's fine. We just can't let A be 0. Okay? And this is going to be a definition. Okay, so we got that definition going, right? We learned the quadratic formula last time. And we learned that we're going to have real numbers A, B, and C. A can never be 0, but B and C could be 0 if they wanted to be. Okay? Note. Here's a note. This formula can be used to solve all quadratic equations. So as long as I have something that's in the form ax squared plus bx plus c equals 0, then I can use this formula. Okay? Let's look at 3 examples. And these are all going to be coming from the problem sets. Okay. Let's look at number 1. So for number 1, I have x squared plus 6x plus 8 equals 0. Okay, so I've got x squared. So I know the highest exponent is 2, which means it is a quadratic equation. That means I can use the quadratic formula up there. Now, normally I would just factor this. And I can, given that we can find 2 numbers that multiply to 8, but at the same time add up to 6. That's possible. But I'm going to save that until the end, when we're going to check our work. All right, so what do we need to know from this? Well, we need to know 3 things. We need to know what A is. We need to know what B is. And we need to know what C is. As long as we can find out what these 3 numbers are, we can put that into the quadratic formula. Okay? Now, looking up here, I have ax squared. So A is going to be the number in front of the x squared. And looking at this x squared right here, if there's no number out in front of the x squared like there should be, then we assume it to be 0. We assume it to be 1. So we know that A is going to be the number in front of the x squared. So A is going to be 1. Then we have to figure out what B is. Well, B is always going to be the number in front of the x. So B is going to be 6. So A is 1, B is 6, and C is what? It's going to be that last number over here, right? The 8. Okay, so let's label these. Now, the number that's out in front of the x squared, we call that the quadratic coefficient. The quadratic coefficient. That's just the number out in front of the x squared. The number out in front of the x, that b right here, that's going to be called the linear coefficient. The linear coefficient. And then the c, which is just the number right here, it's not attached to any x. So this is called the constant term. The constant term. Okay. So now what we're going to do is I'm going to zoom out a little bit, and I'm going to show you how you use the quadratic formula. And I'm going to be using this formula up here. So I'm going to be going back and forth between this question and this formula. Okay? Now the first thing I'm going to do is I'm going to write down my x. My x is never going to change. It's always going to be x. X is a variable, right? It's not going to be a number yet. Eventually it will be, but it's not a number now. Eventually it will be a number, but I'm going to keep the x the same. And then I have to put in negative b. Negative b. So that means I've got to take my linear coefficient, which is 6, and make it negative. So I'm going to start off with a negative 6. And then after the negative b, I have a plus or minus, right? So I'm going to put the plus or minus down. And then I'm going to have the square root of what? B squared minus 4ac. Okay, so what is b? B is 6, right? So I'm going to have 6 squared. 6 squared minus 4. And then I need a and c. So a is 1. I'm going to put that right there. C is 8. So I'm going to put this right here. And then everything is divided by 2 times a. So we're going to divide everything by 2a. So 2 and a is 1, so I'm going to put a 1 right here. So what I just did was I took the quadratic formula and the number that I had for a, b, and c, I just plugged them in. That's all I did. Okay, so now I'm going to zoom back in here and we're going to simplify a few things. Okay, so I've still got my x right here. That hasn't changed. My negative 6 is going to stay the same, and my plus and minus is going to stay the same. And then I'm going to have the square root of what? Well, what is 6 squared? 6 squared is going to be 36. So this is going to become 36 minus what? 4 times 1 times 8. Well, what is 4 times 1 times 8? The 1 isn't going to matter. So what's 4 times 8? That would be 32, right? So I'm going to put a 32 right here. And then everything is still divided by 2 times 1, which would be 2. So I'm going to divide everything by 2. Okay, so we're almost there. We just need to simplify this, and then we'll have a clearer picture of what my 2 answers are going to be. So I've still got x equals -6 plus or minus the square root of what? 36 minus 32? That would be 4. And everything is divided by 2. Okay. So now, what's the square root of 4 going to be? The square root of 4 is going to be what? 2, right? So then I'm going to have x equals -6 plus or minus 2. And everything is still divided by 2. All right. So now we're at the point where we're going to use the plus or minus. Now, you could have a plus or you could have a minus. We're going to do both. So we're going to do the plus first and see what happens. And then we're going to do the minus and see what happens. So this is going to break apart into 2 different solutions. I'm going to have -6 plus 2, everything divided by 2. Or I'm going to have x equals -6 minus 2, where everything is still divided by 2. So that's going to break up into 2 different solutions. And that's because I could have a plus or a minus, right? Okay. So the first one is a plus. So what are we going to get from this? We're going to get -6 plus 2. That would be -4, right? We're still divided by 2. So that's going to give me -2. That's my first answer. Or I could have -6 minus 2, which would be -8, right? Divided by 2, which would be -4. So those are my 2 answers, -2 and -4. So I put them in my solution set. I'm going to have -2, comma, -4. So this is called my solution set. Okay, and that's it. So what we did was we just took A, B, and C and we plugged them into the quadratic formula. And we work it step by step, going kind of slowly so we don't mess up. And we just see what we get at the very end, right? We're always going to have 2 solutions. And that's because of this plus or minus right here. That's what's going to give us our 2 solutions. Okay? And we started off with x squared plus 6x plus 8, right? And before I started this, I said, we could probably just factor this and it would be a little bit easier, right? We would just have to multiply to 8 and add up to 6. And we can do that with 4 and 2, right? So you would end up with x plus 4 times x plus 2 equals 0. And then that would give you your 2 solutions, -2 and -4. So that's an easier way to do it without resorting to the quadratic formula. And that just shows you that you have 2 different methods that get you to the same answers. Okay? Now let's look at number 2 from the problem set. And this time, your answers are going to include a fraction. So let's look at number 2. So 2 says 3x squared plus 8x plus 5 equals 0. Again, my equation is quadratic. I know that because the highest exponent is 2. Okay. So for any given quadratic equation, ax squared plus bx plus c equals 0, we can figure out what A, B, and C are. So A is going to be a number, B is going to be a number, and C is going to be a number. Now, A is always going to be the number in front of the x squared. This time it's going to be 3, right? B is always going to be the number in front of the x. This time it's going to be 8. And then C is always going to be the constant term right here, which is going to be 5 this time. So now we know that the quadratic formula was negative b plus or minus the square root of b squared minus 4ac. Everything is divided by 2a. So we're going to take all three of these numbers and we're going to put them where they should be inside the formula. Okay? So I'm going to have x equals negative b. Well, I just take b and I make it negative, right? I switch the sign on it. So instead of a positive 8, I'm going to have a negative 8. Right? We always start off with a negative b. And then we do a plus or minus. That's going to give us our two solutions in the end. And we're going to have the square root of what? B squared? Well, that would be 8 squared, right? Because b is 8. Good. So I have 8 squared minus 4 times a. Where is a? A is 3, right? Times c. C is 5. Good. And now we're going to divide everything by 2 times a, where a is 3. So I'm going to have 2 times 3 at the bottom. Okay. So now I plugged in all my numbers, a, b, and c. And now we just simplify a little bit, starting with the radical first, because that's where we have the most things that we can simplify. So I'm going to have x equals negative 8 plus or minus the square root of what? Well, 8 squared, that's going to be 64. So I can change this to being a 64 minus, and then I have to figure out what 4 times 3 times 5 is. Well, 4 times 3 is 12, and then 12 times 5 is going to give me 60. So I'm going to have 64 minus 60 on the inside. And everything is going to be divided by 6, because that's what 2 times 3 is. So everything is going to be divided by 6. Okay. So continuing right along, we're going to simplify the radical and see what that gives us. So I've got negative 8 plus or minus the square root of 64 minus 60. That's going to give me 4. And everything is divided by 6. Okay. That's good because we can take the square root of 4. So the square root of 4 is going to give me 2. Right? So I'm going to have x equals negative 8 plus or minus 2. Everything is divided by 6. So now that I have my plus or minus, I can break up my answer into 2 different solutions. I'm going to have x equals negative 8 plus 2, where everything is divided by 6, or I could have x equals negative 8 minus 2, where everything is divided by 6. Whoops. There we go. So I'm taking advantage of that plus or minus. So I could have a plus or I could have a minus, right? That's what's going to give me my two different solutions. So working with the plus first, I know that -8 plus 2 is going to be -6. So I'm going to have -6 divided by 6, which is -1. So that's going to be my first answer. And then I'm going to have x equals what? -8 minus 2, that's going to be -10. Everything is still divided by 6. So it's not going to be a whole number because we can't divide -10 by 6 evenly. So this is going to be a fraction or a rational number. This is going to be, okay, I can divide everything by 2, so I get -5 over 3. So that's going to be my second answer. There we go. We just had to reduce that fraction. So now I've got my two answers. So my solution set is going to be -5/3, comma, -1, and that's it. Those are my two answers. So we started off with 3x squared plus 8x plus 5 equals 0, right? That's what we started off with. And we can factor this without using the quadratic formula, but because of this 3 out in front, you would have had to use the rainbow method or the CAB or whatever you learned in Algebra 1. And, you could factor this quite easily. This would break up into 3x and 5x. And then you would bring down the 3x squared and the 5, start grouping. And then you would get 3x, x plus 1, 5, x plus 1. And then that would give you 3x plus 5, x plus 1. So then if you set those equal to 0, you could see very easily how you would get a -1 from here and a -5/3 from here. Okay? So two different methods. They bring you to the exact same two answers, right? Okay. Let's do the last one that we're going to be doing. This one is number 3 on the problem set. Number 3. Okay. X squared minus 3x plus 10. Equals 0. Okay. So every quadratic equation is going to be in the form ax squared plus bx plus c equals 0. So before we do the quadratic formula, we need to figure out what our a, b, and c are going to be. A, b, and c. Now, a is always going to be the number in front of the x squared. Since there is no number in front of the x squared that we can see right now, we're going to assume it to be 1. So a is going to be 1. B is always going to be the number in front of the x. And since it's negative, we have to write a -3. Since we got that minus out in front, right? And then the 10 is positive, so that's going to be C. C is going to be a positive 10. Okay. So just to remind you, the quadratic formula is -b plus or minus the square root of b squared minus 4ac, where everything is divided by 2a. Okay. So we're just going to plug in A, B, and C where I see them in the formula. So I'm going to have x equals negative b. This is going to be a negative 3. So what I'm doing is I'm putting the minus out in front like I have right here. And I know that b is already negative, so this is actually going to turn out to be a positive 3 when we simplify it. But I'm going to wait until the next step to do that. All right, bring down your plus or minus, and then we're going to have the square root of something. Okay, b squared. I know that b is negative 3, so I'm going to put it inside parentheses and square it on the outside. This is going to turn out to be a positive 9 later. Okay, minus 4ac, so I need a minus 4 times a. What is a? A is going to be 1. Times c. C is going to be 10. And then everything is divided by 2 times a, which is 2 times 1. That's often going to be the case, that your a is going to be 1. And that just means you have an x squared out in front with no number to the left of it. Okay? All right, so all I did was plug in numbers, and now we're ready to simplify a couple things. So I'm going to have x equals positive 3 because of those double negatives. They cancel each other out. Plus or minus the square root of negative 3 squared, which is negative 3 times negative 3. That would be a positive 9, right? Minus 4 times 1 times 10. That's going to be 40. The 1 doesn't really matter that much, but 4 times 10 is going to give me that 40. But I'm multiplying all three numbers together. Okay, so 9 minus 40. And then I'm dividing everything by 2 times 1, which is 2. Okay. So now let's work out what's inside the radical, and we'll go from there. So I have x equals 3 plus or minus the square root of what? 9 minus 40, that's going to be negative 31, I think. Negative 31? I think so. Everything is divided by 2. Yeah, negative 31. Okay. All right, let me get a new sheet of paper and we'll continue on. Now, I will say that we're taking the square root of a negative 31. That is not easy, right? But we can simplify it a little bit. We're not going to be able to break up 31. If you were thinking about breaking up 31 into something times something, well, 31 is a prime number. So it's not going to break apart into any factors that we can use. It'll just be 1 times 31. And that's not very helpful. So the 31 actually has to stay under the radical. But if you remember from complex numbers, if you have a negative number under the radical, you can bring out the negative as I, right? So that's what I'm going to do. I'm going to keep the 3 the same, and I'm going to have plus or minus I. times the square root of positive 31, where everything is still divided by 2. So that stays the same, but notice the only thing that's different is I took the negative 1 out as an I, which leaves a positive 31 on the inside of the radical. So whatever the square root of 31 is, which is going to be a crazy decimal, we're just going to leave that under the radical, right? So we're going to have two different answers. We could use a plus or we could use a minus, right? So if I use a plus, what am I going to get? I'm going to get 3 plus I times the square root of 31, where everything is divided by 2. Or I could use a minus, right? In that case, I would have 3 minus I times the square root of 31, where everything is divided by 2. So I'm breaking apart the formula into two different answers based on the plus or minus. And at this point, there's nothing left to simplify, so you're done. I can't do anything else. Now, if I wanted to, I could write it as two fractions, right? Since I have a common denominator, I could probably write this as x equals 3 over 2. So I'm dividing the 3 by 2, which would be 1.5, but I'm not going to write that, plus I times the square root of 31 divided by 2. So I could break it apart into two fractions like that, where my real part is 3/2 and my imaginary part is square root of 31 over 2. But then, I'm going to have to do the same for the negative answer, right? I could break this apart as 3 over 2 minus I times the square root of 31 over 2. And then after that, I can't simplify anymore. I'm done. So these two are the same answers, and these two are the same answers. So I can write it as a solution set. I could do 3/2 plus I times the square root of 31 over 2, or I could write it as a minus. I could have 3/2 minus I times the square root of 31 over 2. So the quadratic formula is pretty simple once you do a couple examples, and all your answers are going to depend on what A, B, and C are. That's going to determine what kind of answers you get, whether they're whole numbers or negative numbers or fractions or irrational numbers. You could get those, or you could have imaginary answers like we have right here because of that I, right? If the number under your square root is negative, you can always take out the negative as an I, and you would have imaginary answers, otherwise known as complex answers. So these solutions are complex numbers. Okay.